welcome to the stage your president of Idaho Technology Council, Jay Larson.
Thank you. I'm Jay Larson with the Idaho Technology Council. We're so pleased to have you with us on this Capital Connect series in this May 2022. This has been a fantastic month as we've had a lot of Capital Connect. We had a Capital Connect conference 2 weeks ago, and at that conference we had a wealth of information shared with us about entrepreneurs, capital providers that had done extraordinary things in Idaho. We would encourage you to go to the Idaho Tech Council YouTube channel to be able to watch any of those and to be able to see some amazing presentations. During that conference, we had the chance to be able to meet the people that are going to be on our stage here in just a few minutes. But before we get to that, I need to make sure I acknowledge those sponsors that help make the Capital Connect series a reality. They are Alturas and Wilson Sonsini are our primary sponsors, and we also have BR Wealth Management. In addition to them, Deloitte, St. Luke's, and TruckStop.com. So thank you very much for those sponsorships of the Capital Connect series. All right, we're going to welcome to the stage right now with Pitch Aeronautics, the CEO of Pitch Aeronautics, Dave Bennett, and also Zach Adams, the founder and CTO. Come on, gentlemen. Zach, welcome. Thanks, Zach. Thanks so much, Dave. Take a seat, gentlemen. Yeah. So this is, we had you at the Capital Connect series 2 weeks ago. Conference, sorry about that. And you brought out this monstrous, probably, I would say about somewhere 6 to 9 feet in circumference. What I think was one of the coolest things, because this is like a drone on steroids. Yes. So just talk really briefly about that, and then we're going to talk about each of you. Talk about that product that you brought on stage.
Zach, why don't you lead off and talking about the product here? Yeah.
So we've been building a drone. It's not, most drones are just toys that take video. This is fundamentally different. This is an aerial platform. It can carry, a big payload and put it directly in contact with something to do like a robotic task. So instead of, thinking of these things as just flying around, this is a fundamental mindset shift to be able to do these up close and touch-based tasks.
So you're using this obviously when you were talking about this to be able to fly and have a payload on it to be able to do some robotics to correct or fix something that needs to be corrected, right?
Absolutely. So today the most dangerous job in the United States is being a climber. So these guys will climb ropes, they'll hang off helicopters, they go up on scaffolding, and they're 10 times more likely to die than a construction worker. So like 1 in 100 of these guys will die in a 10-year career.
And this is like working on power lines and stuff like that, or?
Yeah, absolutely. So they'll work on any of these aerial assets. There'd be towers, wind turbines, bridges, power lines. Yeah. And the things that they're doing aren't just like looking at it. They're doing non-destructive testing, they're doing maintenance, they're doing repair, they're doing installation.
So if you caught this, Zach said, look at these assets. So this is probably not your average bear. These gentlemen have been trained in the Air Force, the U.S. Air Force, and you still fly F-15s, right, Zach?
I do for now. I just got awarded a sabbatical, or I'll take some time off to focus just on this company, but that has been my Air Force job, is flying the Strike Eagle.
Aha, very good. And Dave, what's your job? What was it in the Air Force and with the Idaho National Guard?
Yeah, Jay, thanks. So I'm an air battle manager, and I did 10 years active duty, and now I've done just a little over 20 in the Air National Guard, which I don't know where that time went, but still having fun with that, and gives us, our team, a real bond because we're all, Air Force, and we have a lot of commonalities, and makes it a lot of fun. But I'd also like to just say a thanks to the Capital Connect team for bringing us on board, letting us have a chance to tell our story, and it's an exciting story.
Oh, it is. I would, the
so
Idaho
thank you.
Yeah, you're welcome, Dave. The Idaho Technology Council is very much focused on what we really liked about was we have a lot of companies that might be further upstream, but it's really fun to be able to see about Pitch Aeronautics because You're a company that might be thought about 6 years ago, right, Zach, when you were doing your PhD. You'll have to tell us about how this started at Purdue. You're a boiler maker. And as you did that, you really look at how it's accelerated the last 2 years. So you're really still an early stage company, but over the last 2 years, you've had some great acceleration.
Yes.
So we'll talk about that in a second. But let's first talk about you both. So tell us a little about, Dave, where you grew up, how you came up with this, how you and Zach met, and
Sure.
maybe we can talk a little bit about that.
So, I'm a native of Virginia, grew up there, went to school in South Carolina. That's the southern accent that you probably detect, but came right out of college and went straight into the Air Force, went active duty for, like I said, 10 years as an air battle manager, forward air controller, just had a blast doing that. Then decided to make a career shift and get into industry. Started down the industry path and really found my love and passion was taking ideas from the whiteboard and getting them to the battlefield. Moved them through technology readiness levels quickly and doing good things with it. My wife and I moved here to Idaho a few years ago, and in that process I met Ian and Zach, and they showed me what they were trying to do with the cyclorotor. And I immediately went, okay, this is a great opportunity. I think we're going to benefit not only, like Zach was saying, the climbers and the people at risk, but also I think there's some great opportunities in government service and supporting some of the warfighter efforts down the road. But
Ian and Zach are the co-founders, is that right?
Correct.
Of Pitch Aeronautics. So.
Yeah.
So that's where you met, but you met them. You didn't come here because of Mount Holm Air Force Base. You came here because
my wife is a medical doctor, and she took a job at the Idaho College of Osteopathic Medicine, ICOM. The new medical school here. So we moved up here.
Which just had their first graduates, right?
Yes, this week. My wife and I do a lot with the military medical students.
Okay.
And so tomorrow we're actually having a big party at our farm for them and honoring them. And so they'll go on, and I think there's 15 of them in this first class. So they graduate Friday.
Congratulations on that. So if anybody wants to go to that party, it's on Battleway. No, I'm just kidding. Okay, that is totally awesome. Okay, so then you came here because of the ICOM, with your wife being a faculty member and teacher there, right?
Correct.
And then you two met. We'll talk about that in a second. Zach, talk about your background.
Sure. Well, I graduated from the Air Force Academy with my co-founder, Ian Gibson, who unfortunately couldn't make it today, but Ian's a little smarter than me. He went off with a Marshall Scholarship and got a couple of master's degrees in England after that, and then was an acquisitions officer in the Air Force, and then got out and did some cool things in industry in parallel to Pitch Aero. I graduated with him, and then went on with a fellowship over to Purdue and did some graduate school to get my doctorate, kind of in this technology that we're now applying for the drone.
And you grew up in Colorado?
I did. I grew up in Colorado,
and then Air Force Academy, and then when you went to Purdue, this is part of your dissertation that you did with you. And what was your study? It was in.
Absolutely. My degree field is in mechanical engineering, kind of more focused in aerospace.
Okay.
But my dissertation and research on it was all on this technology here with cyclorotors and cycloturbines as a different type of propeller that can do some interesting tasks.
So let's talk a little bit about that technology that you were developing, that you kind of came up with this idea while you were working on your PhD at Purdue, and then we'll talk more about how then you took these ideas and how you started the company.
Okay. No, absolutely. So the technology I was working on, it had come out of my undergraduate with a little prior research, was with regard to this device right here. This is a different type of propeller. These blades go about, and as the blades go about, they move relative to this structure. And so you can use it as a wind turbine, take energy out of the air, which is part of the things we studied. But the more important application you can do is you can get thrust out of it. So you can get thrust in any direction perpendicular to this center shaft. and you can change that direction and magnitude just about instantaneously. So you can go from full pushing this way to full pushing this way or this way, faster than you can think about it. And has some kind of interesting applications that we keyed off on. One of those being currently used on tugboats, under the tugboat to help push them around in the harbor. But we thought, what could we do with this technology and some of the things that we've done to advance it?
So does that help you then with, as you get that thrust going different directions, with the stability of, or what's the primary purpose that you're using?
Absolutely. Or for pitch, these have many different applications. The application that we're pursuing has to do with drones. So today's drones move by kind of leaning. You get a platform that'll lean forward and move forward, lean back to move back. So this flight's just this precarious balancing act. And if a gust of wind comes along, you have to lean into the wind. Now, for a large drone, that can take a lot of time to lean into the wind. So you don't stay in exactly the same inch of sky that you need to do these robotic tasks. But if you put one of these on top, now this thing can push back and forth, and you don't have to lean the drone. And because you can do it so quickly, so instantaneously, you can keep the thing in the same inch of sky to do these tasks.
Yeah. So that balance that you get and able to do whatever that work you're performing, you're able to get the stability there to be able to make it so you don't have.
And Jay, not only the stability, but it also gives the drone the ability to go up and touch or push. And as far as we know, that's really the only drone in the world that's going to be able to do that. And one of the fun things we've had as we bring this technology on is developing the use cases. What do you do with a drone that can go up and touch or push something, possibly even put torque on an object? The way that Zach has designed this is you can swap out sensors on the front end of this drone. And because those sensors are out from the prop wash of the hybrid part of our drone, it's unlimited applications of what you can do with this. And that's when it gets exciting, when you say, all right, we can now work with that to help that climber. Or measure cracks, depths of cracks, concrete soundness. So yeah, Zach, you can probably tell a lot more on that story.
Talk about, why don't you do that, right? Talk about some of the applications, or the top 3 applications, if you can, that you're working through. And what we would like to do on this is we always like to talk about the reason you create a business is because you're trying to solve a problem, right? So talk about these 3 applications.
Absolutely. The value proposition here is big. So industrial inspection is a $200 billion market. And just in the market verticals that we're looking at up front, which is bridge and power line inspections, there's more than $1 billion a year for just a touch capable drone. So, for those things, you're either talking about up close inspection tasks or installation tasks. So for bridges, one of the things inspectors will do is they'll rappel down the side of the bridge, and they'll take a little, looks like a business card almost, but it's got these little widths of lines on it. And they compare the width of the line to the width of the crack on the bridge. And then they'll write that down in a notebook and say, well, the crack is this big. They'll come back next year, do the same thing over again. And that's how they track these cracks and how to do maintenance on them. So we built a new sensor that if you get it within a couple feet of those cracks, it can simultaneously measure all of them from the drone without, and then we can help them write that report with that data, much, much faster and much, much safer. Another thing that inspectors will do, both on bridges and wind turbines, is they'll hit the side of the bridge, either their hand or the hammer, and they'll listen to hear if there's like an internal hollow sound, a defect. That can cause, by freezing and thawing cycles or other things. And it's not always visible from the surface. You can't see it. So, what we did is we built a new sensor here. I've got a copy here of it. This goes way out on the end of the drone arm, and it will heat up the bridge with a thermal lamp here. These are halogen lamps. And then it takes high-resolution thermal photos of the surface. And you can see how the heat propagates through, and if it encounters a defect, it changes how that heat goes through. So you can quantitatively see those internal defects. On power lines, we're partnered with power engineers in Boise State University right now on a project where we're building an arm to install bird diverters. So you might not have heard of these, but birds, and it kills like millions a year, will be flying along next to a river, or especially at dawn or dusk, and they won't see the power line. They'll hit it and they get killed from it. So it's an environmental concern, but it's also can cause power outages if they span the line and short circuit it.
Wow.
So we've designed a new payload arm to install these little reflectors essentially on the line that help the birds be able to see it. And today that's done via helicopters at $5,000 to $10,000 an hour.
So that's amazing. So you go to the Rainbow Bridge over in Twin Falls, and that big bridge, which was put, I mean, that's a big span, right? And this would test it out to be able to see where the cracks are, or use this geothermal type imaging thing to be able to see if there's any more structural issues that have taken place because of freezing and other type of things, right? So.
And Jay, this really hit home for me when I was talking to a climber, and his wife was there. And as I was explaining what we're trying to do, his wife summed it up better. And I wish I could have captured her on camera, because she looked at me, she goes, if you can keep my husband off a rope, I know he's going to come home that night. And she said, what he does is really dangerous. And she goes, I'm all for this. So, hurry up and get it out there for us, because we want to use it. So,
yeah, because otherwise you're sitting there hanging, and this is now a simple solution for you to be able to go up. It doesn't have any, and the other one I really like are seriously, birds are like one of the most amazing things when that you have on the planet. And to be able to help with those birds and not have them hit these power lines, that's a big deal. Does it help with any, are you going up to do any repairs on any of the power lines, or can you do anything like that with this?
So we're starting with the low-hanging fruit, which is kind of these tasks that we've described. But the future is kind of limitless when you can envision anything that you'd have to get on a rope or ladder to do an installation or repair. So on power lines, some of the future applications are installing vibration dampers. They're a little bit heavier than a bird diverter. Maybe installing marker balls. And repair work, they have these pins that come out of the insulators that hold them together. They're called cotter keys. We may be able to replace those. One of the leading things that they have to do when they get up on trucks or on helicopters.
So you get this low-hanging fruit, and then you start getting those ones accomplished, and then you have a lot of other activities and problems that you can solve because of the things you're doing.
And I think another key element of the design of the drone enables for future technologies to be added quickly.
Yeah.
So we're not locked into one, it's not a one-trick pony. We're going to be able to, as additional requirements are discovered or needs are met, or customers come back and say, I've got a problem, can you? Well, yes, we probably can. We'll swap out the sensor on the front, or whatever we need to do. I can also see this drone working in conjunction with climbers, so that the drone and the climber are working together. And the bottom line is it's going to speed up, the ability to do inspections, so we can do more inspections. We can do more inspections faster, and we can expand those people that are in that business, in that line of work. We can expand their business model.
Plus, it's more accurate, right?
And it's much more accurate.
Much more accurate.
Yeah.
Interestingly, on what do you call your drone?
So we've named our drone, the full thing, not just this, is called Astria. One of our student interns on the project came up with a name. It's after the Greek goddess of precision.
Oh, really?
So we like that.
Astria.
Yeah, maybe that's one of the Limfax, as it's hard to pronounce. But
yeah, Astria. Yeah, you have to keep an eye on that one. That's good. So now on this one, Zach, you have a patent. Is it patent pending, or have you already got the patent approved on this?
So on the cyclorotor, so on this device, we have an awarded non-provisional patent from the USPTO. And then on our entire drone, the configuration and some of the methods that we use to, put that exactly where we want it in the sky, we have a non-provisional patent pending. We expect that to go through. It just takes several years to work its way through the bureaucracy.
How long did it take you to get the patent on the cyclorotor? Is that what you call this?
Yeah, it took about 3.5 years, which I think is about the going rate of time.
Yeah, so you sit there and you wonder why. Yeah, we talked about this being, you've been in business for 6 years when you first came up with this, but really the last 2 years, because you have to have all these things need to be worked through the process. What we always say is that in order for a company to really start really getting the lift it needs, sometimes it takes anywhere from 10 to 15 years. But yours is coming pretty fast now. So let's talk about that. Why have you got more traction over the last 2 years than you previously? What's been taking place?
Well, it all comes down to coming to Idaho, right?
Yeah.
This is the place to be.
Yes, let's hear it for that. Coming to Idaho.
Absolutely.
Love that. Yep.
Yeah.
Okay.
But when we got here, we were able to partner with Boise State University and have some of their technology help as well. But together, we jointly applied for the iGEM grant, the Idaho Grant for Entrepreneurial Mission.
Idaho Global Entrepreneurial Mission.
Global, that's it.
Yeah.
Yeah, that makes more sense. But we were able to get about $300,000 in a series of 2 of those grants from the state to mature this technology, both the sensor side and the drone side, and that allowed us to bring together a larger engineering team, students onto the project, and actually design, build, fly, and demonstrate the core prototype of the entire technology. And without that support, that would not have been possible. So that's been instrumental.
It was huge, and I'm really proud of the team too, because they took that seed money from Idaho and did something amazing with it. They stretched every penny out a long way, and got us to the point where we really accelerated what we were doing with not just the technology, but that team with the iGEM also opened up, along with the Capital Connect and other people there, opened up the doors to all the other entrepreneurs here in Idaho. And I think Idaho is really coming. When you look at what's coming into the state and what's already here, it's a great partnership. And we're pretty excited about where we're going to be, and I can't wait for this time next year to see where the big jump that we made.
Yeah.
Because it's coming. Yeah.
It's kind of a Moore's Law type thing, right? Because now you're starting to see this acceleration of what you're able to do and the implementation. Dave, when you take a look at that, and you look at this 300 million, I'm sorry, 300,000, that's a little bit different in the rounding area, sorry about that. But $300,000 you're able to ultimately get from iGEM. If you're looking at that, that helped you really get to the point where you can refine the whole product, right?
Absolutely. We're flying now. And so when I first came on board, we were close, but weren't there yet for the initial test flights.
So meaning the prototype, well, you had the idea of what you wanted to do, but now you have the prototype, you're able to do all of the implementation of it, so you can really prove
That's correct.
the aspects of it?
Yeah.
Yeah, what iGEM did is it got us through that prototype development, and it's getting through us a couple of initial customer demos
Okay.
with the sensor and with the drone. And then what we're taking on the next stage here is to take that and truly transform it into a recurring revenue stream for the company. So, this is a aviation technology. I mean, there's a lot of risk that we had to buy down. And now that we've bought down that risk, we can take it and transform it into something that's actually, profitable.
Yeah.
And having revenue come in every month is a great thing. Do you have customers yet?
So we have a series of initial testing partners, which is really what we want at the stage. We want their feedback, and then eventually we'll convert them into their customers, but not before we get them a great, the proper product.
And they're helping you refine the product and how you can do everything, which is
Absolutely.
really critical for you right now. So you're still in that product development stage. What point do you think you'll move from the product development to the point where you'll actually start having customers pay you money?
I expect that to occur in the next 12 to 18 months.
Okay.
That's part of our major push.
And that's 12, that's like you're talking about, Dave. You're about a year from now, you can really see that, because that's when you really
Absolutely.
start having the transformation of a company, right?
We're on target, if not a little ahead of schedule. And I think with that, there's a responsibility to these users. This isn't something we want to put out there that's not, almost ready. It needs to be 100% ready because of the nature of what they're going to be using it for. And so it's really important to have it dialed in. So the iGEMs has really helped us with that dial in part. And,
So let's talk a little bit about this really quickly. A lot of times when you have a product like this, you have to have the hardware side and then you have the software side, right? So the firmware that kind of comes together with the whole thing. What's happening right here with the product development with respect to the hardware and the software?
Absolutely. We've developed software in parallel to this. There's
Yeah.
kind of two pieces for that. There's one is flight control software. So one of the major members of our team and a professor from Boise State was concentrated in that flight controls. This is a very narrow discipline of engineering that's very difficult. Like, how do you actually tell Astria how to fly to make it that precise? And so that's something that we've done as a part of that development effort. So that's kind of a trade secret. Another software push is to be able to take the data that you get and transform that into something that is most useful for the customer, right? To directly accommodate their value proposition, their problem of needing this data from reports or for feature maintenance. And so we've been working with Boise State as well, and we have a post-processing algorithm and software package for the active thermography sensor. So it can take these thermal images and translate that into where is this defect, how bad is the defect in the bridge, and what can you do with that?
Nice.
Yeah. And one of our future government, future customers is also in the government, and we're going to be taking this drone to help modernize the Army test ranges because they have really similar needs to industry inspections, and so we're excited about getting into that market as well.
Wow. Yeah, you can just see so many applications because now you're actually talking about something that could actually go out. You might see some of this when you could go out and repair a spaceship or, I don't know, in outer space. Because now you're going to, I'm just going way out there. I know this might be, I'm way out there with my vision on this, but this thing is going to be, yeah. So your partners, really quick, let's talk about that. Yeah, boy, I heard Boise State, I heard the state of Idaho with iGEM and the Idaho Department of Commerce. Do you have anybody else, because that's really important to be able to have those type of connectivity and intellectual capacity that's helping you. Anybody else as your partners on this?
No, absolutely. So for power lines, we partnered with Power Engineers, one of the
great company,
great companies, and we're working with them on this payload development project, and hopefully we'll demo that later this year. Pretty exciting. With respect to bridges, we have one of the county highway districts in Idaho is working with us.
Okay.
And then the state of Idaho Transportation Department is also being one of our testing partners there. For rope access, we have a company called Extreme Access. They do rope access bridge inspections throughout Idaho, Montana, and Oregon. As well as down in the south in the wintertime when it's too cold to climb ropes in Idaho.
That would be, yeah, that could have happened today, I mean, with the snowball, right?
Yeah, he's probably not out there today.
No.
But, and then we have a civil engineering firm that they have to do inspections prior to doing major repairs on bridges, specifically in the region as well. So. And the most remarkable thing that we found is that this is such a needed, capability, and it's so expensive and so dangerous for them to do it now, that everybody that we've asked to test the technology with, they are eager to do it.
Oh yeah.
They've always said yes.
Well, you'll be seeing that the audience will be, as you've seen some of the applications we were talking about, some of the video of it. When you watch that, you start going, "Wow, what a great solution!" Right? Yep. I mean, so I can just tell you that. As you get more introduced to the product, you'll see a great application and a lot more applications down the road because of the technology that you developed at Purdue. So that's awesome. Okay, let's talk about last part, the future of pitch aeronautics. Where do you see yourself? I know we talked about a year. Where do you see yourself over the next year to two? What are the key areas of focus that you're going to have so you arrive where you want to be in 2 years?
Yeah, I think we're, Zach and I will tag team on this a little bit, but, we're in that final stages of the product development and the product testing and refinement, and then it's going to be immediately starting to meet the needs of our customers. From there, I see that it's going to be the rock hitting the pond that's going to just expand out to as new customers, both on the commercial and in government. Services. This time next year, I think we're going to be, looking at how are we getting this drone out to customers. So we'll be entering some of the production phase and meeting that initial customer base. So it's exciting. Zach, what are some of your thoughts?
Absolutely. Our big thing right now is. And there's some opportunities coming up that you're welcome to sign up and hear more about on our website. But is with respect to our seed round, we're taking our prototype and getting it to recurring revenue. So we're expecting to have 5 to 10 paying customers that pay for the subscription model with our drone, and that will occur sometime in 2023. And then beyond that, we're going to scale the company further to enter other types of tasks, other market verticals, and grow the company. So in 5 years, we expect to see thousands of these things out to do these tasks that today you only envisioned people getting out on a crane. Or
with the robotics and the aerodynamics that you've been able to put together here, it's pretty impressive. So.
And Jay, something else we're excited about too is, our product is almost entirely made of parts from the United States. And so as we grow, we're going to help others to grow. And that's exciting to be a part of that as well. And then our team itself is growing. We've gone from a very tight-knit core team, which is just fantastic. There's nothing like working on a good team. And now we're bringing on new partners and people that are bringing in specific skill sets that we need to get us to where we need to be next. And we've also had some very wise counsel of people here that are local, that are experienced entrepreneurs, and their input is invaluable. To sit across the table over a cup of coffee, and they've been where we are, and they go, okay, here's something you need to think about, so that's been great.
That's fantastic, and I think that's a really good point, because you don't do it without the talent of what you had from your team, right? So, and the name of the product again is
Astrea.
Astrea, and the god of precision, the goddess of precision. I'm almost wanting to say this is like the Wright brothers of here in Idaho that are helping us with the future of flight, but the application of robotics and how you can do things. So that's...
Well, Jay, I got to tell you, it was a little humorous. The first prototype flight, we did it on my farm, which is, so we were flying one of the most advanced drones, and the first flight occurred in a cow pasture. And so, gotta love it.
Yeah, you do. No question. Yeah, right. We're going to talk about this. We'll have to find this. Okay. Well, thanks. So if they go to your website, this might be the way we end, because I know that future funding activities might take place. So would they go to your website? And what's that website?
Absolutely. You just go to pitchaero, pitchaero.com. And there's an opportunity in there to put your name and email down, and we can give you some more news about some stuff that's upcoming and exciting.
So stay tuned on that. Go to pitchaero.com, and you'll be able to find out more. And here's the beauty, what we'd like to ask. We heard that in 12 to 18 months, there's going to be some major things going on with Pitch Aeronautics. We would love to have you back to be able to give us an update on this technology. Would that be?
Absolutely.
Absolutely.
Good. Okay, so
we'd love to do it.
Well, thank you all for joining us today for Capital Connect series this May 2022. You heard from Pitch Aeronautics, which is a fantastic company that is making some major progress. But again, it's still in the product development. That's major improvements that's made. We're going to have them back on in 18 months to be able to figure out more that we can do. But in all the things that we do, innovation is the key at what's happening here, and Pitch Aeronautics is a good example of that. So again, we'd like to thank our primary sponsors for the Capital Connect series, Alturas, Wilson Sonsini, BR Wealth Management, Deloitte, St. Luke's, and truckstop.com. And we truly would like to be able to thank Pitch Aeronautics. Zach, you and Dave, thanks so much for being with us today. Thanks so much. Keep innovating.
Thank you so much.
Thanks.